Hi, my name is Rachel.
Hi, I'm Jack.
Hi, I'm Paige.
Hi, I'm Tina, and we chose San Diego State to our math trail because there's, as you can see, a lot of different geometric shapes around our campus.
Circles are found all over campus. As you can see, there's one on this clock right here. In circles, there are four major parts to circles: diameter, radius, minor arc, and major arc. First, I'll talk about diameter. To find the diameter of this circle, you just have to go from the 12 o'clock to 6 o'clock, draw a line from 12 to 6. That'll cut it right in half and make it your diameter. To find the radius, you just get the center point and go to any of the numbers 12, 1, 2, 3, all the way to 11. And for the minor arc, it's right now, if you can see, it's 12, 15, and that mark from 12, 15 is the minor arc, and the major arc is the rest of the circle.
Okay, so we're in the bookstore and I picked up a cube, and how we know it's a cube is because the base is a square, but also all the other faces are a square and they're equal. And there are 6 faces total in this whole cube, and there are 8 edges if you count where the faces are attached together, and then there are 12 vertices where the corners meet. And then there's also, if you're trying to find the lateral edges, there's 4 because that's where the lateral edges are on the cube. And then there's also 4 lateral faces, which are the ones that are round.
Commons, and we have an abundance of polygons, and I found some on the roof. So within the big triangles, there are smaller triangles on the edges that are right triangles, and there are also quadrilaterals. The quadrilaterals are trapezoids because they have one set of parallel sides and then the other set is not parallel.
In the technology section of the bookstore, and I have 2 similar laptop cases. Now we can find the scale factor of these laptop cases by finding the ratio between the corresponding sides. So we can divide this side by this side, and that will give us the scale factor. So as you can see, this case is smaller than this one. Now in similar items, the angles remain the same. So this angle is the same as this angle. Also, for surface area, you can take the scale factor and square it. So the surface area is the amount of space that is covered like this. And then for the volume, you can cube the scale factor. So a bigger computer is going to fit in this one than it's going to fit in this one.
Symmetry is found all over campus, and there's 2 main parts to symmetry: rotation symmetry and reflection symmetry. Right here, there's a square, and for rotation symmetry, you can rotate it 4 times, 90, 180, 270, and 360, and they'll all be the same. They'll still look the same. Then for reflection symmetry, you can cut it right down the middle where this crack is, horizontally where that other crack is, and then 2 diagonals to make it 4 reflections of symmetry.
So now that our math trail has come to an end, we will be recapping what we went over today. Our first stop in student services, we had Jack discuss circles and their major components, and he compared them to a clock. Next, we had Tina in the bookstore, where she explained polyhedra and used a cube to show the different vertices, edges, and faces. Next, we saw Rachel in East Commons, where she described polygons and showed us an example of triangles as well as trapezoids. Next, we had Paige in the technology section of the bookstore discussing scale factor and different ways we can use scale factor to compare similar objects. Lastly, we had Jack discuss symmetry and the reflectional and rotational symmetry of a square.